This is the continuation of our previous lecture. In this lecture, let us talk about serial in, parallel out, shift register. So here in this type of shift register, we will give the input serially, we will in the data and we will get parallel output data. So again we will consider 4-bit serial in, parallel out, shift register. So it is comprised of 4 flip-flops. Suppose this is the F0, this is the first flip-flop, F1 is the second flip-flop, F2 is the third flip-flop, and F3 is the fourth flip-flop. These flip-flops have common clock pulse, and these are positive edge triggered flip-flop. So again, this is the input. So these are also cascaded. The input of first flip-flop is the output of second flip-flop. And the output of second flip-flop is the input of third flip-flop. Similarly, the output of third flip-flop is the input of fourth flip-flop. Okay. Now in this case, suppose I have 4-bit data, which is 1, 0, 1, 1. So on first clock pulse, so this data will in serially. So this would be the input of this flip-flop. So suppose initially the output are 0, 0, 0. So after first clock pulse, this output would be 1, and the remaining output, you know that the output of the flip-flop is the same as its input. So remaining would be 0, 0, 0. Let me use some different color. And when the second clock pulse will arrive, so this would be the input. So this input would be the output of this flip-flop. So it would be 1, and this would be the input of this flip-flop. So the output would be 1, and the remaining output are 0, 0. On third clock pulse, this input is 0, so this output would be 0, and this output would be 1, this would be 1, and this would be 0. On fourth clock pulse, fourth positive edge trigger clock pulse, this would be the input. Now it will become the output 1. This input would be the output of this flip-flop 0. This input would be the output of this flip-flop. So this input. So we on fourth clock pulse, we will get the output 1, 0, 1, 1, 1. So we can load the parallel data in this case. Here we can parallelly load the data. So shift the data. So this type of shift register is called serially in. Here we are going to uh, going to serially in the data enters serially, and the output we have parallel output. So also uh, uh, this circuit is similar to the serial in and serial out shift register. The difference is that here we are using these outputs for last case for serial in serial out shift register. This output, the final, uh, flip flop output, we were taking into account. Okay, thank you. In the next lecture we will discuss parallel in and parallel out shift register. Thank you so much. That's it.